Hello, my name is Mariann Molnár, and this presentation is about methods to enhance farm animal welfare through animal housing technology certification and alternative farming systems. This presentation aims to introduce some of the key findings of my project, which was supported by a Tiny Beam Fund Fellowship for academic researchers and was completed in the summer of 2024. Now, as you can hear on my voice, I'm just recovering from an illness. And to limit any distractions this may cause, my wonderful colleague Katie Koroleski, who is a postdoctoral researcher at the Animal Welfare Programme of the University of British Columbia, has kindly offered to narrate this PPT for me. Thank you very much for your interest in this project. Should you have any questions or comments, please do not hesitate to reach out to me. And now, over to you, Katie.
Out of the approximately 56 billion animals that are raised every year, at any given time around 31 billion are housed in highly specialized, large-scale, intensive farming operations. While more data is needed to understand the exact proportions, in the US 99%, while in the UK 85% of all animals are known to be raised in intensive farming conditions. In most high-income countries, a transition to intensive farming has been ongoing since the mid-20th century, while investments in developing countries or transition economies, those transitioning from a centrally planned to a market-based economy, have started to follow this trend. Those countries which are part of the European Union have already invested in intensive systems, while other European countries, or EU accession states, in the Balkans, for example, are facing pressures to intensify. And in the backdrop of all these changes is a very dominant narrative that prescribes intensification. This narrative presents intensive farming as the only economic way to provide large amounts of safe and affordable food for growing human populations. Not only are intensive systems communicated as the single viable farming method to feed the world, but the significant expansion of intensive systems by an estimated 68% until 2050 is widely encouraged and incentivized. Contradicting these opportunities and pressures for intensification are major reform efforts initiated by the EU, which aim to ensure a good balance between economic, environmental, and animal welfare interests. The Green Deal, the Farm to Fork strategy, and the End the Cage Age Citizens Initiative aim to deliver significant improvements in farming conditions. Negotiations are still ongoing, but the big question is, how can we provide a good life for farm animals in the midst of intensification? This presentation aims to look into an aspect of intensification that is generally overlooked in reform efforts, and that is the impact on the supply industry of intensive animal farming tools and technology. This industry is upstream from farmers in the value chain and has been suggested to indirectly influence on-farm standards. Indeed, most EU minimum animal welfare standards try to regulate the quantity of space animals are provided with and the quality of care that farmers provide, without regulating the trade of these technologies. So, the first aim of the presentation is to provide a better understanding of the supply industry of housing technologies. This work is timely because of the recent publication of the Commission's Strategic Dialogue Report on the Future of Agriculture, the ongoing revision of animal welfare policies, and a possible introduction of a comprehensive welfare labeling scheme. So it is very important to make informed decisions. This year has also seen some very significant farmer protests in the EU, so it is of paramount importance to look at these issues in a complex way and ensure a reform that is good for animals and is also supported by farmers. The second aim of the presentation is to introduce two practical solutions based on real-life case studies that can address problems associated with intensification and provide a better balance of interest for farmers and their livestock. The first solution is a system of mandatory technology certification that assesses technologies before being sold to farmers, while the second is alternative systems that are less intensive than the average farm, but still economically viable. So, why are intensive farming technologies and their supply industry so important? The on-farm technology supply sector is highly consolidated, with 5 major corporations controlling 60 to 70% of the worldwide market share. In 2022, the market value of animal farming technologies reached $21.4 billion US, and by 2032 is estimated to expand even further. And statistics from 2023 show that 63% of all trade was carried out in Asia, the Pacific, and North America, 25% in Europe, and 13% in Latin America, the Middle East, and Africa. So, the industry is quite substantial and now has a global reach. In this project, an in-depth assessment of leading farm technology suppliers was carried out. 5 companies were assessed per sector for pigs, dairy cattle, laying hens, and broiler chickens, which means that the communication materials of 20 companies were studied. Data came from a content analysis of online and printed brochures and other materials that were made available through web pages and agricultural fairs. All companies had a wide range of products, especially to manage the housing and environment, such as pens, flooring, and lighting, and to manage the handling and management of livestock, including sensors and monitoring systems. But in contrast, there was a very limited range of products offered that directly contribute to welfare. Enrichment tools were noticeably limited, and apart from cow brushes and dust baths for pens, there really was not much of a choice. Instead, the content of brochures gave details on the physical descriptions of housing systems, information on warranty and servicing, and client testimonials. It is also important to mention that only positive terms were used to define technologies, emphasizing the quality and efficiency of the technologies. There was much emphasis on the modern, optimal, durable, hygienic, pleasant, functional, and innovative features of these tools, which claim to reduce labor hours, increase yields, and decrease costs. Often, these descriptions are backed up with some data on minimizing feed waste, for example, but when describing welfare contributions of products, there was no data to back up claims such as animal-friendly or housing of healthy, happy, and stress-free livestock. In addition, there was much emphasis on communicating optimized and sustainable use of space and resources, with an emphasis on the economic viability of operations and smart farming solutions that support on-farm decision-making. However, the brochures did not go beyond claiming that animals are provided with species-specific, comfortable, and ergonomic housing systems. Therefore, the assessment of brochures concludes that welfare claims were presented in an overly positive light and lack any reflection on the challenges and limitations of large-scale, specialized indoor systems. When these claims are compared to other, more objective sources that capture the day-to-day realities of farming, it becomes evident that brochures do not tell the whole story of animal farming. Earlier studies indicate that farmers are not fully in control of welfare standards on their farms. Investments into expensive indoor housing and husbandry systems necessitate their use, and farmers find it difficult to change or modify these if regulations or consumer expectations change. Technological lock-in also limits farmers in their efforts to make major improvements to animal welfare conditions within existing intensive farming operations. It is therefore safe to say that industries upstream in the value chain from farmers have a direct influence on on-farm standards. While product brochures strengthen the impression that animal housing tools and technologies are fit for purpose, they do not account for the many challenges and negative production externalities that farmers will have to deal with when using them on a daily basis. These issues are generally unaccounted for in scientific literature, animal welfare-related policies, and advocacy practices, and therefore require more attention. So, in the present context of animal farming, we need to think about ways to improve farm animal welfare within intensive systems. The first solution that this project has identified is based on an in-depth case study of the Swiss mandatory animal housing technology certification system. This real-life example is based on interviews with authorities and farmers, observational data collected during farm visits, and other written sources from web pages and peer-reviewed publications. Technology authorization was first initiated in Switzerland as early as 1981. Since then, mandatory authorization was also adopted in Austria, while non-mandatory technology assessment is available in Germany. The core of the certification system is outlined in Article 5 of the Swiss Animal Welfare Act, which states that mass-produced housing systems and equipment for the keeping of animals for the purposes of profit may not be advertised and sold without prior authorization from a service designated by the Federal Council. It is designed to limit the uptake of farm technologies that may potentially harm animal welfare, control and improve the standard of production technologies available on the market, encourage farmers to work with the best fitting technologies suitable to their specific circumstances, and ensure the effective enforcement of national legislative standards. The Swiss Farm Technology Authorization System is therefore a tool, like EU legislation, to find a good compromise between production goals and the welfare needs of animals. But it goes further and works to ensure a mutually agreeable consensus between the supplying industry and regulating authorities as well. It is a tool to provide additional checks and balances within the free market of intensive housing technologies in a way that is acceptable to all parties concerned. Certification takes place through a complex and consistent set of procedures and an iterative working process, as seen in the illustration below. More information is available on page 34 of the project report, and this report is referenced at the end of the presentation. The certification process has 5 key components. The manufacturers or importers apply to the Federal Food Safety and Veterinary Office, the BLV, for certification and submit detailed documentation of the technology and associated user manuals. These manuals are normally shared with farmers after purchasing technologies, so the mandatory certification system already goes beyond existing practices to make sure that farm technologies sold are fit for purpose. During the initial assessment, authorities review scholarly literature to identify how the technology impacts animal welfare. This method is most effective for technologies that already have been studied and have not undergone any major modifications. Practical testing is carried out for new or modified technologies. During this procedure, veterinary, physiological, and behavioral tests are carried out to determine the short and long-term welfare outcomes of the technology in question. Tests are carried out in the establishments of the BLV or in some exceptional cases on commercial farms. Where possible, comparative tests, for example, a farrowing crate examined in comparison to a farrowing pen, are also carried out to assess the performance of different systems against each other. Depending on the findings, a temporary, conditional, or final authorization may be provided by the regulating authorities. To reach an official decision, Regulators are free to make decisions within their own authority. Alternatively, they can consult an expert advisory board when needed. Manufacturers have the right to appeal against the decision of the BLV. In this case, the official procedure is repeated. Authorities may work intensively with manufacturers to come to a mutually acceptable solution. Alternatively, the application may be rejected. Probably the most important advantages of the system are associated with a transparent and simplified administrative process, yet a very comprehensive scientific evaluation method. It allows technology suppliers to refine their product range and sometimes even develop new technologies with the help of authorities that negotiate standards along the way. This is why farm technology certification does not limit or damage the business interests of manufacturers. Instead, it enhances the development of more reliable technological solutions for farm animals kept in intensive conditions. Certification also helps authorities to keep track of changes in production methods and update legislation accordingly, and altogether improves housing conditions. Challenges include that in some cases, datasets from different behavioral, physiological, veterinary, and productivity indicators can be inconsistent or inconclusive. In this case, experts evaluate indicators on a case-by-case basis, and an iterative process of data collection, analysis, and consultation until the best possible decision can be made. There is also a need to balance different interests, which can be tricky when economic and welfare interests are at stake. If the data provides straightforward answers, decision-making is carried out by the certifying authority at its own discretion. However, in more complex scenarios, an expert advisory board is consulted to negotiate the final decision. Altogether, these challenges are well managed by responsible authorities and facilitate a close cooperation between farmers, the supplying industry, and responsible authorities. In a nutshell, with careful planning and positive communication, solutions are available to significantly improve farm animal welfare, even in free market conditions. Based on the findings of this study, it is possible that the Swiss example could be most easily applied in transition economies that are just starting to intensify animal agriculture. Countries that are already invested in intensive indoor housing will also benefit from the introduction of the technology authorization. However, the intention must be communicated well in advance so that both the supplying industry and farming communities may understand how it will operate and prepare for the changes. In this process, it is vital to communicate with members of the industry in a positive, professional, and proactive manner to ensure cooperation between interested parties. Contacting experts of the Swiss Federal Food Safety and Veterinary Office and the Austrian Animal Welfare Center is highly recommended to find out more about mandatory certification. These experts will be able to provide first-hand knowledge of how the system works best and will be able to advise authorities of transition economies from EU member states, candidate countries, and non-EU members. Alternatively, non-mandatory testing can also be explored through the network of the German Agricultural Society. So, the Swiss case study suggests that we can improve on-farm animal welfare even within intensive farming systems. Contrary to mainstream beliefs that view traditional or alternative farming as inefficient, laborious, and expensive, a new type of alternative farming system has recently emerged, offering important contributions to food production, a wide range of social, economic, and environmental benefits, and a significant potential for development beyond the established intensive industrial model of animal agriculture. Data on this second solution are based on an in-depth case study from Hungary, and additional data from other agricultural enterprises located in Germany, the UK, and the US. Sources include in-depth semi-structured interviews with farmers, observations on farms, as well as books, web pages, conference presentations, and peer-reviewed publications. So, what is alternative farming? Alternative farming is an umbrella term for various types of non-conventional, extensive to semi-intensive farming methods. Various examples include agroecological or regenerative agriculture, permaculture, circular agriculture, holistic or biodynamic agriculture, and certified organic agriculture. But it is also more than just a farming method. Truly alternative systems invest in or transition to setting up a diverse farming enterprise where animals are integrated into other product lines, such as arable farming, fruit or vegetable production, with the farming that enables the production of a wide range of high-quality products. To optimize internal revenue retention, it is also essential for farmers to coordinate production, processing, and trade, all within the same enterprise. Hence, these systems are dissimilar to the model of intensive farming, where producers specialize in a single commodity, produce large quantities of it, and when finished, sell products to the processing industry. Key features of alternative farming systems include the scale, which can be small to medium. In comparison to intensive farming methods, production speed is relatively slow. Input is mostly independent from external industrial inputs and aims to use local resources and skilled workforces. Use of technology and machinery is minimal or limited to a specialized range of multi-purpose tools. Animal breeds are slow growing, and they are also well adapted or local or traditional breeds. Invasive procedures are rare. And finally, animal housing is semi-indoor to outdoors. The differences between the two systems are clearly apparent when all externalities are fully accounted for and product quality is adequately assessed. In alternative farming operations, output is much more than a range of final products. These systems respond to different challenges associated with farming and engage in activities that offer additional positive contributions to farmers, local communities, farm animals, and wildlife in and around farms. Alternative farms depend on biodiversity, functional ecosystems, and ecological services, which makes them clearly distinct from intensive farming approaches. The production of a diverse set of high-quality, nutritious food that is sold through short value chains is probably one of the strongest attributes of alternative systems because it provides farmers with access to growing niche markets and more predictable incomes. The mainstream market operates by a different logic, but in this case, farmers have a certain level of control over the price of their finished products, which can better be adjusted to production cost than in intensive systems. Food produced in alternative systems also requires less investment into fixed technologies and costly external inputs, which means that they remain versatile and easily adaptable to local conditions and any major changes in consumer preferences or markets. Alternative farmers also use transparency to their advantage and proactively communicate about their farming methods and invest in ecologically sustainable farming methods that also provide higher welfare standards, which makes them very appealing to consumers. Farmers themselves acknowledge that the most important challenge associated with alternative farming systems is to reach the right mentality. The switch in attitudes, the acceptance of the fact that production is possible, economically feasible, and improves the resilience of farming communities is vital. But this crucial step can only be made if alternative systems are assessed based on their own merits and are not compared to intensive farming operations. Both systems operate in and adjust their production methods to the logic of their own markets. Indeed, many farmers believe that alternative methods are overlooked or ignored because of their constant comparison to intensive farming operations. So, while alternative systems cannot match the yields, volumes, and profits necessitated by the mainstream market, short value chains operate just as well, and farmers do not need to sell their products to processors. While at present there still is only limited knowledge or training possibilities for farmers on alternative farming systems, most alternative farmers are actively learning from one another and seeking collaboration on opportunities with other like-minded producers. Some of them also try to raise awareness on the methods they use, and some key publications are already available in English that are worth consulting. Finally, alternative systems require good planning and execution to ensure economic sustainability, which is something that farmers achieve over time, especially by limiting reliance on external inputs and achieving a self-sustaining circular system. Based on the findings of this study, it is possible that the application of alternative production systems can be most beneficial for transition economies, because it will allow them to preserve farming communities and develop a small-scale model of agriculture without investments into large, intensive, highly specialized indoor farming systems. In addition, in countries where farming is very intensive, the expansion of alternative production systems could offer opportunities for farmers to access niche markets. For more information, the books of working farmers who have invested or transitioned to alternative farming systems are highly recommended, especially The Return of Nature to a British Farm by Tree, The Book of Wilding by Tree and Burrell, and Salatin's You Can Farm Guide. So, as the examples of exemplary alternative farming systems suggest, we can improve on-farm animal welfare beyond intensive farming systems, offering benefits to different geographical regions, farming contexts, scales, and models. Alternative systems can also be adapted beyond animal welfare to address some of the most pressing environmental, climatic, and biodiversity-related issues associated with intensive agriculture. Please note that all of the information introduced on mandatory technology certification and alternative farming systems is available in an in-depth project report that can be accessed through the QR code on this slide or the Tiny Beam Fellowship link provided on this slide. Mariann would like to thank the Tiny Beam Fund and the UBC Animal Welfare Program for their invaluable support in this fellowship project. Thank you for your attention. Goodbye.